Good morning, my dear students. So we will continue the problematic part session of the module 1 of fluid mechanics subject. Okay, we will directly move to the problem without wasting time. I have already copied the questions so that I can save our time. See here, the space between two square flat parallel plates, the space between two square flat parallel plates are filled. Okay, it is filled with oil. Each side of the plate is 60 centimeter. The thickness of the oil film is 12.5 mm. The upper plate moves at 2.5 meter per second, which requires a force of 98.1 Newton. So all the values that they have given, just they have tell us to find that to determine the dynamic viscosity of oil in poise, kinematic viscosity of oil in Stokes. Fine. So we will solve the problem. Okay. So given is directly there. So what I do, I'll directly solve the problem. What I want first, I want the dynamic viscosity. I'll solve for dynamic viscosity. Okay, now what we know formula, what formula we know, that is tau is equal to dynamic viscosity into du by dy. Okay, then again what we know that force is equal to what, this tau is equal to what, force by area. Force is equal to shear stress into area. Okay, see, now what I will do, I have force, they are given the force, so force is given as 98.1 Newton. Okay, when requires a force of 98.1, the upper plate moves, so U is given, that is 2.5 meter per second. Then oil film thickness dy 12.5 mm. Then what is given, the space between two. Okay, then plate dimension is given, that is 60 centimeter. Okay, that one side of the square plate, no, so I'll take side is 60 centimeter. See, now what I have, they have given value of force, so I'll take this formula. Okay, by this formula I can calculate what, I can calculate the tau, this one. So tau is equal to force by area. What is the force? 98.1. What is the area? It is square plate, so 60 centimeter is given, it will be 0.6 meter. Okay, as area of the square is what, a into a. Oh, okay, so it will be what, 98.1, 0.6 into 0.6, so the value of tau will be 98.1 into divided by 0.6 square, it is 272.5. so 272.5 Newton per meter square. Okay, now I got tau. Now what I need to find? I need to find what? Mu. So tau is equal to mu into du by dy. From this, what I do, see here, I'll take this mu, which is equal to, I'll multiply that side, tau into dy by du. Okay, what is tau? 272.5. What is dy? 12.5 into 10 power minus 3 divided by u, du, u 2.5 meter per second. So this implies the value of dynamic viscosity is 272.5 into 12.5 into 10 power minus 3 divided by, oh, 1 minute, 272.5 into 12.5 into 10 power minus 3 divided by 2.5. It is 1.362. What is this? Newton second per meter square. But in what value they have asked? They have asked to find in poise. How to convert it? So just multiply by 10. So 1.362 into 10. Okay, what it will be? Mu is equal to 13.62 poise. So first part of the problem is over. Now I'll take the second part, that is kinematic viscosity. So remember the formula of kinematic viscosity. What is the formula? Kinematic viscosity, either nu or neta, anyone you take, okay? But whenever you are writing this, just mention what is this, okay? So neta eta is equal to kinematic viscosity. What is that? It is the ratio of the dynamic viscosity to the density, correct? Okay, now but I don't know the density of what? Oil, okay? But in the question they have mentioned here that specific gravity of oil, specific gravity of oil is 0.95. So we know the relation between specific gravity and density, okay? So this specific gravity is nothing but density of oil to density of the standard. Standard is what? Water, okay? They have given this value. So what is this value? It is 0.95. So 0.95 density of oil, density of water is what? 1000 kg per meter cube. Then density of oil is equal to 1000 into 0.95, it will be 950 kg per meter cube. This dynamic viscosity we already know. Eta is equal to, what is that? Take in this SI unit system, okay? 1.362 divided by 950. It will be 1. Your kinematic viscosity will be 1.433 into 10 power minus 3. So what is the unit? Meter square per second. Eta. Okay. What they have asked? To give the value in Stoke. Okay. So Stoke is what? We have to convert. So convert in centimeter square per second. So what we have to do to convert? It is in meter square. We have to convert to centimeter square. So eta is equal to 1.43 into 10 power minus 3. So meter square. If you multiply with 10 square, or 1 minute, 10 to the power of 4. So 1 meter is 10, right? So 1 meter square, it is 10 square will be 4. Okay, don't confuse. Meter in the centimeter square avaga. So meter square is the 10 square into square agate. So 2 to the 4, 10 to the power of 4. So yavade value meter per second iddaga, if you multiply with the 10 to the power of 4, it will be centimeter square per second, which is nothing but 1.43. Okay, this 10 power minus 3, 10 power, it will be cancelled, 10 power 1, which is equal to, neta is equal to 14.3 Stoke. Itanu multiply adaga point akade hogutte. Okay, so this is the value of neta, that is in Stoke. 14.3 stoke. So whenever you want to convert meter square into centimeter square, so square is the term. If it is not square, you have to multiply with 10 to the power of 2. Because of it is square, we have to multiply with 10 to the power of 4. Okay, I hope you understood. So next problem we will go. So next problem is the surface tension. This is the problem on the surface tension. So in surface, whenever the concept of surface tension comes, you should remember some of the formulas. What is that? Surface tension is equal to what? PD by 2. Okay, it's not PD by 2, it's PD by 4. What is this? Pressure, diameter, so divided by 4. Or else remember this that we had done in the theory, that is P is equal to what? 4 sigma by D. This sigma is what? Surface tension. Surface tension. You remember this formula so that you can convert it later. Okay. So according to this problem, you have to remember this, but this is universal, right? Pressure is equal to 4 sigma by D. Okay, you have to remember this formula, and based upon the cases, if it is a hollow bubble, whatever type of the question they give you, based upon that you can take the value. So I'll write first given whatever they have given. So before that, I'll discuss with the question. The surface tension of water in contact with air are, so they are giving surface tension 0.0725 Newton per meter. The pressure inside a droplet of water, so they are giving the pressure inside a droplet of water is to be 0.0 Newton per centimeter square, greater than the outside pressure. Calculate the diameter of the droplet of water. We should calculate the diameter. Pressure is given. Okay, surface tension is given. So what is given, I'll write it. So surface tension is equal to 0.0725 Newton per meter. Correct. Next, pressure, small p. Small p is given, that is 0.02 Newton per centimeter square. Okay, in the last problem we have converted, right? So I have to convert it into the meter square. Newton per meter square. What I can do? 0.02 into, so what I did there? 10 to the power 4, right? 10 to the power of 4 Newton per meter square. Okay, 0.0, so it will be meter square. Okay, now what formula I know? We know that this pressure P is equal to 4 sigma by D. So we have the value of this, and we have to find this. So what I do? I want D, right? So I'll send this D this side. So this implies D is equal to 4 sigma by P. Okay. So D is equal to 4 into 0.0725 divided by P is what? 0.02 10 power 4. So the value of D will be 4 into 0.0725 divided by 10 to the power of 4. It is 1.45 into 10 power minus 3. It will be in meter. Okay. Or you can also tell that, so diameter of the droplet is equal to 1.45 mm. So this is how we do the problem whenever the problem on surface tension is given. Okay. Now let us see another example. Find the surface tension in a soap bubble. See, a problem on bubble of 40 mm dia when the inside pressure is 2.5 Newton per meter square above atmospheric pressure. So what with the formula we know? We know the formula, that is pressure is equal to 4 sigma by d. This is for the liquid water droplet. Now they are giving for bubble. Bubble means what? 2 circumference. Okay, there will be 2 circumference of the bubble. So then P is equal to this 4 into 2 into 2, that is 8 sigma by d. So this formula we have to use whenever bubble problem is given. So bubble problem. Okay, use refer the PPT. You will understand why 8 sigma by d. Okay, whenever the problem is given, the surface tension has to be found of a bubble. When it is related to soap bubble, then we will get 2 surface of that bubble, inside surface and outside surface. That's why 8 sigma by d. Okay, next, dia of bubble, BUBBLE, that is 40 mm. So you convert it, 10 to the power of minus 3 meter. Then pressure is given, small p, 2.5 Newton per meter square. What we need to find? We need to find the surface tension. So P is equal to 8 sigma by d, which implies sigma is equal to P into d divided by 8. So surface tension is equal to 2.5 into 40 into 10 power minus 3 divided by 8. The value of surface tension will be 2.5 into 40 into 10 power minus 3 divided by 8. It is 0.0125. 0.0125. What is this unit? Newton per meter. Surface tension unit is 0.0125 Newton per meter. Some easy problem will be given. Just you need to remember the formulas just to practice. Okay, I have given this 2 questions. So I hope you understand. Please solve more problems so that the formula will be practiced and you remember easily. Next we will go some problems on capillarity. So note 3, capillarity. I am just writing the expression. So expression for capillary rise. Okay, expression for capillary rise. What is the expression for capillary rise? When you place the tube, glass tube, which is open both the sides, okay, the water will rise and make a meniscus like this. Then if we take a tangent here, some value of theta will be there. Okay, and this, the tangent force will be your surface tension. Okay, then this angle is theta, this angle is theta, and the height of capillary rise is what? H. So in the capillary rise, the main thing which they ask is the problems on the height. What is the formula we discussed? We discussed is your H. H is what? Height of capillary rise is equal to, I already discussed the formula, 4 sigma cos theta by rho into G into D. So this is the formula for capillary rise. So whenever there is capillary fall, what is the formula? So H is equal to 4 sigma cos theta by rho G into D. It will be same, but here we have to note down theta, the value of theta will be obtuse. Okay, it is greater than 90 degree, and the height will be negative for capillary fall. How is that? So if you consider a vessel, so consider this as mercury. So the water will inlet and it will fall a meniscus like this here only. So the surface tension is this. When we draw a tangent, this theta value, and this will be the height. H will be negative. Okay, so sorry, this is not the theta. Theta is what? According to definition, it is the angle between the glass tube and the surface, the tangent. So this will be theta. So it will be obtuse. Okay, greater than 90 degree. H will be, so it is submerged in the mercury, right? See the image in the PPT. Okay, it is negative. H will be in negative. So same formula should be used. So let me do 2 examples on this capillarity. So let me write the questions. So next problem is, calculate the capillary rise in a glass tube of 2.5 mm dia when immersed vertically. So it is immersed vertically in water and mercury. So 2 different cases will come. First we will write down the given and we will solve the problem one by one. So ಒಂದು ಗ್ಲಾಸ್ ಟ್ಯೂಬ್ ಇಟ್ಟಿದಾರಂತೆ ಎಲ್ಲಿ ವಾಟರ್ ಮತ್ತೆ ಮರ್ಕ್ಯುರಿಯಲ್ಲಿ. ಸೊ ವಾಟರ್ ಅಲ್ಲಿ ಇಟ್ಟಾಗ ಸರ್ಫೇಸ್ ಟೆನ್ಷನ್ 0.0725, mercury ಇಟ್ಟಾಗ 0.52 Newton per meter, and they have also given the value of specific gravity of mercury is 13.6. okay, and angle of contact, this theta is related to what? Mercury, 130 degree. okay, and another term, whenever water is given, what is theta value? Theta is 0. Angle of contact, okay, with glass and the surface tension. Okay, theta is 0 there. Now I'll solve one by one. So given, I'll take, so whatever they have given, I'll write it. So first is given, that is diameter of the tube 2.5 mm, means what? 2.5 into 10 power minus 3 meter is given as diameter. Next, surface tension of water, directly given here. Surface tension of mercury. Specific gravity of mercury is given. Why? To find what? Density. So specific gravity of mercury. So with the help of what I can do? So I want density of mercury. So what I can do? Specific gravity into 1000 will give me 13.6 into 13600 kg per meter cube is what? Density of the mercury. Why I need this density? So whenever you come with the formula, that is 4 sigma cos theta rho GD. Okay, whenever you see the question only, the formula should come to your mind, so that whatever you want, the data you want in the data you want to solve your problem. So it is what? 13,600 kg per meter cube. Okay, this is direct substitution problem, no circus is here. So first one is water. So whenever is water, theta is what? 0 degree. So if theta is 0 degree, what will happen to the formula? H is equal to 4 sigma cos theta by rho GD. So cos theta, so cos 0 is what? 1 only. Now what will happen? 4 0.0725 1000. Density of water is what? 1000. 9.81. Acceleration due to gravity. D is what? 2.5 10 power minus 3. So height of water is equal to calculating, it is 0.1182. okay, and this is in what? Meter. Sorry, this is in meter. So what happens? The capillary rise of water is 1.18 centimeter. Okay. Now for mercury. So for mercury, so theta they have given as 130 degree. Next, same formula, H is equal to 4 sigma cos theta divided by rho GD. So I'll directly substitute 4 into sigma. What is that? Mercury surface tension into cos 130 degree obtuse more than 90 divided by rho 113,600 kg per meter cube into 9.81 into 2.5 into 10 power minus 3. So I'll get the value of H as, see here, 4 into 0.52 into cos 130 divided by 13,600 into 9.81 into 2.5 10 power minus 3. So it is what? Minus, see here, the answer is only came in minus, that is 4.0 into 10 power minus 3 meter. So whenever I convert that into centimeter, I am getting at minus 0.4 centimeter. So whenever you calculate the height or capillary rise or capillary fall with respect to mercury, the height of fall or rise, in the case of mercury it is fall, it will be always negative. So 0.4 centimeter. So I hope you understood the form. You understood how to solve. Now another type. Here all the items will be given. We have to find the diameter of the glass tube. Okay. See here, the capillary rise in the glass tube is not to exceed. So H is given that 0.2 mm. Determine its minimum size given that surface tension of water is given. So I'll directly go to the problem. Here everything is given. We have to find the diameter of the glass tube. Okay. What is given? Given height H, that should not exceed 2 mm. So 0.2 10 power 3 meter. Now sigma is what? 0.0725 Newton per meter. Okay. 10 power minus 3, this is mm alpha. So let D be the dia. Let D be dia of glass tube. We have only one formula, just we have to substitute in that. So it is with the water, right? So water means theta is what? 0 degree. So directly I'll apply the formula. H is equal to 4 sigma divided by rho G into D. So 4 into 0.0725 divided by 1000 into 9.81 into D. So H we know, that is 0.2 into 10 power minus 3. So it will be 4 into 0.0725 divided by 1000 into, however you solve, okay, you will get the answer. So I'll what I do is I'll calculate this into, okay, wait, 4 into 0.0725 0.29, 1000 into 9.81 is 9810 into D. So what I want, the value of D, the value of D will be, just multiply here and divide by 0.29. So 0.2 10 power minus 3, 9810. So it is your answer is 0.148 meter. So we can also write that D as 14.8 centimeter. Okay. So thus the minimum dia of tube should be 14.8 centimeter, because it should not exceed what? 0.2 mm of water. The minimum diameter which we should maintain is 14.8 centimeter. So this complete the problematic part of the first part of module 1. So next I will go to the theory part of pressure and its measurements in the coming session. So thank you. I hope you are understanding. Have a good day.